Lines and planes, part 2, answers, full solutions. Question 6. Plane pi has a vector equation, blah, blah, blah. Verify that pi does not pass through the origin. Okay, let's do it. So let's just sub in the origin into our parametric equations for our plane and check if, I guess, S and T are constant at that point. Okay, so our parametric equations are x equals 2 plus s plus 2t, y equals 1 plus s, and z equals 3 plus s plus 2t. 3 plus s plus 2t. Okay, awesome. So then if we replace x, y, and z with all zeros, because the origin is at 0, 0, 0, we just need to solve these and see if the s's are constant and the t's. Okay, so I'm going to just take this guy right off the bat. Since it doesn't have a t, I can actually just solve for s in this equation. So I can figure out that s equals -1. And then I might as well sub it into one of the equations. Doesn't matter, but I think I'll just pick number 1. So 0 equals 2 minus 1 plus 2t, and I'll solve for t. So 2 minus 1 is 1. So -1 equals 2t. So t equals -1/2. Okay, so that's using equation 1 and 2, so x and y. Then with my z equation, I'm just going to sub those values in and see if the left side equals the right side. So the left side is equal to 0, and the right side is equal to 3 plus s, which is -1, plus 2t, which is -1/2. So 3 minus 1 minus 1, because these guys cancel out, which is 1, for sure. Did I do that wrong? Yeah. No, I think you did it right. Okay, cool. Either way, left side does not equal right side. Awesome. Okay, so done. Verified that the plane does not go through the origin. Okay, now we want to find the distance from the origin to the plane. So those are those questions where like you have a plane and then you have the origin. I don't even know where the plane is. I just randomly drew it there. The origin, and you want to figure out like, you know, how far is this plane to the origin? So we already know the origin is at 0, 0, 0. So it would be really nice to know this point right here. Then we can just find the distance. So remember what we're going to do is we're going to turn this thing into a line. And we're going to find out where that line intersects the plane, because that'll give us that point. So first things first, we need an equation for this line. Because we already have an equation for the plane. So let's get step 1. Let's make an equation for the line. Okay, we know the line's perpendicular to the plane, so we're going to need a perpendicular vector to the plane, which unfortunately our plane is in vector form. So let's do the cross product with those two direction vectors to get a perpendicular vector to the plane. Okay, so I'm going to take my two direction vectors, which are 1, 1, 1 and 2, 0, 2. And I'm going to do cross product to get my normal vector to the plane. So doing that, I get 2, 0, -2. So doing like that, that, that. I totally messed that up. I really wrote them slanty. It should have been those two. Okay, anyways, that's what it equals. Okie doke. So now we have a perpendicular vector to our plane, which is the direction vector for our line. So that's going to be our line's direction vector. Then the other thing we need for an equation of a line is just a point on the line, and we know the line is going to go through 0, 0, 0. So I think we've got it. Equation of our line is x, y, z equals 0, 0, 0 plus t 2, 0, -2. because we got a direction vector for our line and a point. So we got equation of a line done. Okay, I think whenever we did intersections of lines and planes, we always took the parametric equations of the line. So let's just write those. 2t, y equals 0. Weird. Is that what it equals? And z equals 0 minus 2t. So we always took the parametric equations of the plane and subbed it into the scalar equation of the plane. So if you want to do it like that, then we need the scalar equation of that plane, which is pretty easy to get because we already have the normal vector. So to get the scalar equation of the plane, this is the first one on this page. It's taking forever. So ax plus by plus cz plus d equals 0. And then we need a point on our plane, which we have one, 2, 1, 3, right? Yes, we do. So 2, 1, 3. So we can find out what d equals. So if my math is correct, d equals 2. And the scalar equation of our plane is 2x minus 2z plus 2 equals 0. A lot of 2's. Could probably just divide those all by 2 and make that look better. But I'm not. Okay, so next, let's find the point where they intersect. The line and the plane. I'm just going to take my scalar equation of my plane, this guy, and I'm going to insert my x, y, and z. So I got 2 times 2t minus 2 times negative 2z. Oh yeah, y is 0. Plus 2 equals 0. And then I get 4t plus 4t equals negative 2, 8t equals negative 2, so t equals negative 1/4. Okay, cool. So next, now that we found the point where we haven't found the point where they intersect, we found the t value, we got to sub that back into our parametric equations. So x is equal to what? 2t. So 2 times negative 1/4, which is negative 1/2. Check. And then y is equal to 0. And z is equal to negative 2 times t. So positive 1/2. Ooh, my kids are coming. I'm gonna have to stop this in a second. Okay, so now we have a point on the plane where they intersect is going to be the point negative 1/2, 0, 1/2. Now all we have to do is find the distance. The distance from the point 0, 0, 0 to negative 1/2, 0, 1/2. And we do that with the distance formula, which is like the Pythagorean theorem. Magnitude of a vector. Just subtract the x, y, and z coordinates, square them, add them together. Excuse me. And we get square root of 1/2 is the final answer. Okay, 3 more questions. Question 7. Determine if the line intersects the plane, and if so, state the solution. So we have an equation of a line and an equation of a plane in different forms. So first of all, let's make sure they don't intersect. Or they do. Let's see if they do. Okay, sorry. This is our plane. And our line... Oh. Someone's sad. Okay, negative... I don't know if you can hear them. Negative 6 plus t... 4, 1, negative 3. Okay, so this is our plane. And this is our line. And we're trying to find out if they intersect. So right off the bat, if I wanted to check I can see that the normal vector of my plane is 5, -2, 4. And for my line, I can see that my direction vector is 4, 1, -3. So remember, the normal vector to your plane is perpendicular.
Hi, I'm Sydney.
They're here. So if I actually just do the dot product between my normal vector and my direction vector, then that should equal 0 if they're parallel. Right? Because this would be like a plane, this would be like a perpendicular vector. And then if my line was actually parallel to the plane, the dot product of two perpendicular vectors is 0. Okay, I don't know if that was clear. So, this one, it's 4 times -3. So that's going to equal 6. Okay, so therefore, they do intersect. Yes.
Let me see what you're doing.
I'm just recording a vectors video. Okay.
Ooh.
I'm just putting the answers so that kids can see it. So let me just try to do this. Okay, so then I would recommend putting it in parametric form and then subbing in the x, y, and z in parametric form and solving for t.
How did you do it red?
You can just change the colors.
Oh, cool.
So it becomes 5, -17. Let me just finish this video. Plus 4t minus 2, 7 plus t plus 4, -6 minus 3t equals 23. And then I'm not going to show all my steps, but if you completely solve that, like expand all the brackets, totally solve that, then t will equal 73 over 3. Boom. Okay, well, almost done. So then the point of intersection, you just sub that back into your parametric equation. So x equals -17 plus 4 times 73 over 3, which will equal 241 over 3. It's a lot. Y will equal, what is y? 7 plus t. So if you just are awesome at fractions, then that's 94 over 3. And z is equal to -6 minus 3 times t, which equals -79. So that's your point of intersection. Is that what the question asked? Okay, you can write after. 1 second. So POI is 241 over 3, 94 over 3, and -79. I have 2 questions to go. Question 8.
Mom,
Oh, this is a fast one.
Mom, what are you supposed to do to put the colors down?
You know what? I'm going to continue this video after. But to answer your question, you know what? I'll just give you the quick answer. Question 8, no, they don't define a plane. And question 9, the answer is x minus 5 equals 0. You have to write the scalar equation of a plane. So you actually just take the direction vectors, do the cross product. So like, oh God, I just did that wrong. 0, 1, 0, 0, 0, 1, 0, 0, 1. Wait, I'm just thinking. Cross product, which will give you the vector 1, 0, 0. And then you have a point. So you just sub in like 1x plus 0y plus 0z plus d equals 0. And then you sub in a point. So your point is 5, 4, -7. You just sub it in. And you find out that d equals -5. And then that's your equation. Shortest video. Well, not really. Okay.